Thank you all for attending BCI's Rootkits workshop at Avengercon last week. I know that we didn't get a chance to go over every single exercise because we ran out of time. That's really common for us at Boston Cybernetics. For a short thing like this, we want to give you way more materials than we could go over, with the idea that you have some take-home stuff that you can work on, and if you have questions, you can DM us later. I'm happy to help you out with some of the exercises that we didn't get a chance to get to. So with that in mind, we didn't quite get a chance to finish porting diamorphine to MIPS, and I thought that was a really neat thing to show everybody, just so you could have like a final product and get a feel for how we can take the stuff we learned in the user mode portion and then the kernel mode portion, and porting existing capabilities to new architectures and come out of it with this new capability. So when you are done and you've got everything working, like we talked about in class, like the architectural specific components of the rootkit that need to be ported to, diamorphine originally, the open source stuff on GitHub will work on x86 and work on ARM. And when we're done, we should have something that can work on the MIPS architecture, which is pretty neat. So over here on the left, I've got our MIPSL embedded system. So it looks like that. We're running Linux, 5. Something, but it's MIPS as opposed to x86 or ARM. This is the same thing we were using in the workshop. And over here, I've got the final version of our rootkit. So I'm going to make it just like we were in class. This directory helps us, it specifies the cross-compilation toolchain. So we build that. And then just like before, I'm going to SCP this thing into our VM. And then I'm going to SSHN. And if we look around, we've got the rootkit there. And nothing is loaded just yet, so I'm going to load it. Okay, we see some stuff over there suggesting that we've successfully loaded. Now, before we had ported the capability to hide this module, right? To unhook it from the list of LKMs that are on the system. So this is what we would expect, right? It's the rootkit starts hidden, but we hadn't yet hooked syscalls. So let's test and see if we can now hide, for example, something with diamorphine secret. Because if we successfully hook the syscalls to get directory entries and they're working, then we shouldn't see it. And we see that diamorphine secret.py is hidden. Excellent. Another thing that we hadn't tested yet was to elevate privileges of a non-root process to root. So currently I'm root. Let's get over into the user account that I've created. And this user account can't access the root directory. But if I send a new kill signal, which is just for the rootkit, then I'm elevated to root, and I can see inside of the root directory, even though before I was a user mode process. And then lastly, we were unable to remove our module because we couldn't find it because it was hidden. And so now that we have the hacked version of kill, we should be able to unhide. You'll see over here some print case statements. And then we can see that diamorphine is reconnected to that linked list, and we can remove it. And then at that point, we can see that secret thing, that secret file that we wrote. It's no longer hidden because we've removed our rootkit from the system. All right, thank you everybody. I had a great time at the workshop and I appreciated your attention and all your good questions, and we'll see you next time.